Hi, this is Chris and Rafał from PagePro. Today we're discussing top common mistakes that hurt core web vitals. Rafał, thanks for joining. I'm very happy that you can share your experiences. So core web vitals are very important for web projects because they're impacting bounce rates, they're impacting general user experience, and when you have it done properly, you have better conversions. So this is one of the important aspect. The second aspect is that thanks to good core web vitals, you can have SEO boost from Google, so your positions can rise. And Rafał was working, and he's still working on a very big medical project. And after implementing SEO and performance updates, this project positions jumped from average 20 to 8, so it's very big improvement. Congrats, Rafał.
Thank you.
And yeah, Rafał, let's go straight to the meat of this session. So please share common Next.js mistakes that are hurting core web vitals.
I think we can start with CSS-in-JS Libraries, like styles components. The reason they hurt the site space speed is they introduce a lot of overhead because they have to run JS on the client. That JS is hashing class names, is injecting style elements into the HTML, and every time you inject one, the browser has to recalculate the styles for all of the whole page, which is quite expensive. And the perfect solution for that is Tailwind, because all of the calculations, which is to only compile the CSS file, a single CSS file, that's important to note, with only the classes that are actually being used. So you get as small CSS file size as possible, and then you get no runtime overhead. There's no JavaScript running on the client side.
Yeah, so as Rafał mentioned, Tailwind can be a solution for some of the mistakes, especially in CSS-in-JS aspect. But we're going to record additional video when Rafał is going to tell you how to fix all of the mistakes. So please subscribe and check our next episode. Rafał, so what is the next mistake?
Yeah, so staying in the topic of CSS, that's the CSS modules. So even though you may not be using CSS-in-JS library, you may be using CSS modules. And what I found is if you combine CSS modules with lazy loading of components, these can also introduce a lot of overhead, because when you load, when you lazy load a component, its styles also get injected into the HTML, and that's again causes style recalculations. And if that's done in a critical moment, like when the user clicks a button, types some input, it can increase INP. So it's best to just either have one big file, which is actually a pretty old way to do it. I mean, just stick to Tailwind.
Okay, cool. What's the next one?
Another thing is Next Dynamic. People often forget about using it, and it gives you a very convenient way of lazy loading components, which is great to reducing the initial bundle size, which directly translates to better LCP, FCP, INP, in general a better experience for your users. The way it works is the components bundle is only being fetched and run if the component mounts. This is great, for example, for models. You never have models that are immediately shown to user when you visit the page. That's usually in response to a user action, like clicking a button. Maybe a request finishes and you want to notify a user that it finished, and you show the model. So what Next Dynamic does is that bundle sits in a separate chunk, and when the command is actually rendered, the browser fetches the bundle and shows the model, and the user does not notice the difference. Well, he notices the speed difference.
Yes. So I think in Google Page Speed Insights, it's a common thing that you see the message reduce JavaScript bundle size, and I guess this is directly impacting the bundle size, right?
Yeah, because if the bundle size is big, the browser has to parse it all. The browser has no knowledge that this part is not being used. You have to tell the browser what's not being used.
Great. What is the fourth one, right?
Yeah, the first one would be using Next font. So web fonts can actually slow your site. That's because browsers will wait for the font to be loaded before continuing with rendering. And a lot of third-party providers of fonts require you to first send a request to their CDN. Then you get back a small CSS file with font face declarations. And once the browser parses that, then it sends the request for the actual fonts. So you get 2 requests just to fetch the fonts. You can't beat physics. Every request takes time. So you're introducing overhead, even if the network is really fast. And then of course, if that's a third-party CDN on another domain, there's DNS lookup, which also takes time. So Next solves that by hosting that font on the same domain. It also performs a couple of optimizations, so you can declare which font weights you want to use. So for example, if you have a variable font and you only care about 400 and 700 weights, which most sites would do, you can tell Next.js to only include those, so that reduces the size of the font. Similarly, you can define subsets, so if you know your site is going to only use English, you don't need to include Cyrillic, Greek or other letters. That also can save a couple of kilobytes. And also Next automatically preloads the font for you, so that ensures that the font is loaded as soon as possible, and you don't have a flash of unstyled content.
Perfect. Yes, I think in the next video we are going to discuss when it's better to self-host the font, when to use Google Fonts, how to get specific subsets of characters, and I think the very important aspect is also to have a good design. So it's good to make sure that designer is putting just the fonts that are really crucial for the website, because sometimes it's additional font and we need to load additional files. Okay, what's next?
So the next one would be Next image. So sometimes people, even though they use Next.js, they still use regular image tags. But Next.js components saves you a lot of time and work because everything works almost out of the box. So that includes lazy loading the images. So if you were to just add a regular image tag, if you have 10 of them on the page, all of them will be fetched immediately, slowing down your site. Next image ensures only the images that are above the fold or are just about to enter it, that only those are being fetched and rendered. Next.js also provides you with the ability to optimize those images. By default, that happens through Vercel, which is the creator of Next.js, but you can also provide a loader prop that allows you to use any other service. So that could be your CDN, that could be a website that hosts images and allows you to do transformations on them. There's also an option to preload images. That would be for Next.js versions older than 16. That was called priority. Now it's being called just preload. And that's great for example, hero images. Any image that can be picked up as the LCP element, it's worth preloading it. That's a big difference because the browser will start fetching it as soon as it's discovered in the HTML, and that's going to be on the top of the HTML, so that it makes a big difference. And the second thing would be using the sizes prop. So by default, next image component, which is another benefit of it, will generate a source set, which is a list of URLs to different sizes of the same image, and then the browser can pick the smallest one that will fit the viewport. Because obviously, if you have a 4K image, that's maybe fine on a 4K display, but if you're on a phone, you usually want to load the smaller one, especially since small phones are slower. So with sizes, you can tell the browser how big the image can get. So for example, if you know that on desktop your image will be spanning the whole width of the site, you can tell that to the browser, but then on mobile it might be even smaller. It might always be 300 pixels wide, and you can tell the browser, okay, fetch the 300 pixel one, don't fetch the big one.
Of course. Yeah, great. I think this is directly impacting LCP and in some of the cases CLS. So I think this is very important to have good strategy for rendering pictures and also hosting the pictures. You need to find a good service in terms of performance and also cost for generating sizes and providing pictures to the final users. Great. What's the next point?
So now the next one is Next script. This is another component offered by Next.js, and I think the most common issue with that causes bad performance of site are third-party scripts. Most of the sites are bloated with third-party scripts. So what the component allows you to do is you can choose the moment the script gets loaded. There are 4 strategies. The first one is before interactive. That means that the script will be executed before hydration. That's for the most critical scripts. So for example, for polyfills. The second one, after interactive, that happens right after the hydration. So that's where you want your analytics, maybe some widgets, something like that. Third one is lazy on load. That means it tells the browser load the script once you have no more work to do. So that waits for the hydration, that waits for everything else to run, and then once the main thread is free, the browser will run it. So that's great for non-critical scripts, so maybe chatbots, things like that you don't need. You don't care when they run, as long as they run. And the fourth one is worker. This is still experimental. It allows you to run the script in a web worker, which comes at a trade-off because you can't manipulate the DOM with it, so not all scripts would work with that. But if you have a script that does a lot of work and does not interact with the DOM, it's a great way to do it.
Great. So those 2 last points are about Next.js components, the image component and script component. So it's very important that Next.js is working to have the best performance, and in each release we have some performance updates, but we need to be up to date. So we need to understand what is changing in image component and script component to utilize the latest Next.js features. Great. So what we have left?
So the next one would be React Compiler. React Compiler was recently made stable by the React team, and the Vercel team moved it from the experimental section to the stable one. So all you have to do is install a Bubble plugin and then toggle a setting in Next.config. And React Compiler will take care of optimizing all of your components. So it will get rid of unnecessary renders by memoizing objects and components. It will hoist object declarations out of the components to prevent unnecessary renders. And I think the average improvement on the React, it says so on the React side, is about 15% per site.
Nice.
And all you need to do is install a package. So that seems like a good trade-off. And I'm sure it can help with with page speed.
Cool. Yeah. What's the next one?
So the next one would be returning too much data to the client. So
also about the bundle size, I guess.
Well, not really the bundle. That's just about the data. So it doesn't matter if you're using Pages router or the app router. If you return something to a client component, that actually gets sent to the browser, and the browser has to parse that. So if you want to do as much parsing, mapping, filtering, and so on as you possibly can on the server, and only return what's relevant to the component. Just this morning I was looking at a site that returned a 7 megabyte payload from get static props, so you can imagine the page speeds of that site was not great. Basically the rule to follow is do as much as you can on the server.
Of course.
And the next point that's kind of a related topic, which is relaying too much work to client JavaScript. So again, you want to do all of your mapping on the server. Everything you do on the client will directly impact the page speed, especially FCP and LCP.
Yes, because I guess if you're doing that on the server side, you also can cache it. And when you're doing that on client side, every time the JavaScript needs to run, for example, filtering or sorting and stuff like that.
Yeah, and even if you do use the React compiler, which will memoize all of it, memoization itself is expensive, and then it also uses memory. So there's no benefit to doing it on the client. So if you're not using any client-related things like window, the address, or something like that, do it on the server.
Of course.
Okay, and the last one is doing heavy work or importing a lot of code into the middleware. So the middleware runs before every page, before every API route. Of course, depending on your config, because you can limit where it runs. But if you import, for example, say a whole loader library and a moment.js library, that's a lot of bundle size, and it needs to be loaded every time someone requests a site, a page, and that can slow it down a lot, and that increases TTFB. And TTFB has direct impact on both FCP and LCP, so it's important to do as little job as possible and try not to use libraries, or use the libraries that have great tree shaking, and import only the functions you're using.
Okay, great. Yeah, so that was a very very useful list of 10 mistakes that you can do in Next.js that are hurting core web vitals. So if you have problems with core web vitals, you can just send this video with this list to your developers, and they can check if they're implementing latest Next.js functionalities, and maybe they have the problems that Rafał mentioned, so they can resolve them. If they can't, they also can watch our next video, because our next video will be about how to fix those issues. So thank you, Rafał, very much. This is your first time on the video. I think you're doing very well. So thanks for your willingness to record this, and let's record the next one. Thank you very much.
Yeah, can't wait.
Thanks. Bye bye.
Bye.